Construction accidents are common because unforeseeable failures causing significant harm to both people's safety and stakeholders' financial success. Risk assessment is the most important part of the risk management. Such issues may occur during the risk assessment of building construction. First and foremost, building disasters are caused by a combination of risk factors. To avoid being misled by random statically connection with no logical validity, it is vital in safety evaluations to safety logical linkage between plausible changes. Second, every construction project is different. Recent data from previous projects may not always be appropriate in estimating the risk status of new project.
So next, we went to the site which is located at G3-M. The activities there are mostly maintenance because the buildings are already old and many things need to be repaired. The construction began early in the year 2023 and until now it is still ongoing. During site visit, there are so many activities there that we already recorded. So the first activity is maintenance roof. Maintenance roof is the routine inspection of all vulnerable locations on a roof that may become a problem. Depending on the kind of roof, whether residential or commercial, maintenance will be done annually, biannually, or quarterly. Investing in roof care contributes significantly to the long-term health of your roof. Even if your roof was professionally erected, you should have an annual maintenance assessment. When you receive an annual maintenance check, possible issues are identified, the life of your roof is extended, and you have a peace of mind. The second activity is electrical work. Electrical work includes connecting or disconnecting electricity supply wiring from electrical equipment, as well as manufacturing, constructing, installing, removing, adding, testing, replacing, repairing, altering, or maintaining electrical equipment or an electrical installation. Examples of electrical work are building low voltage electrical wiring installation, installing electrical equipment into a coupler or interconnector. The third activity is concreting. Concreting is the process of combining cement, water, and aggregates such as sand, gravel, or crushed stone to produce concrete. A long-lasting and powerful construction material, the procedure consists of multiple processes, including site preparation, concrete mixing, pouring, and finishing of the material. Concrete is a necessary building material, and its use is vital in the construction sector. It is a versatile substance that is long-lasting, sturdy, and cost-effective. So, the next activity is plastering. Plaster is a protective coating put to a brickwork to protect it from outside contaminants and damage. It is made up of a mortar and a binder which is hardened that helps to plaster to adhere to the wall. Furthermore, depending on your requirements, other elements such as plastics and cellulose, coloring, heat insulating, water repellent, dehumidifying, fireproofing, and waterproofing components may be added into the plaster. So, the last activity is painting. Paints and varnishes are used in building and other engineering works for covering the surfaces of wood, metal, masonry, plastered walls, slabs, and others, to protect the surfaces from atmospheric influences and to preserve them from decay, oxidation, and corrosion. It is to improve the appearance of surfaces. It is also used to shield various buildings and structures from the impacts of water and sunlight.
Next, identification of potential hazards at the site. There can be various potential hazards at a site depending on the nature of the site and the activities conducted there. Here are some common types of hazards that may encounter. First, exposed electrical parts, temporary lighting, open power distribution panels, and insulation on cables are a few examples of exposed electrical elements. Potential shocks and burns could result from these dangers. These objects should be guarded well, and any exposed parts should always be checked and mended right away. Handling sharp objects. On a building site, there are several sharp hazards such as tools and machinery, shattered blades, nails, and screws, as well as various blades, saws, and knives. Always use caution when working with or around such objects, and managers and all employers should make sure that only workers who have undergone the necessary health and safety training and are wearing the proper protective gear utilize hazardous equipment. Material and manual handling. The phrase manual handling refers to various physical actions involving one or more workers lifting, holding, setting down, pushing, pulling, carrying, or moving an object or a load. Airborne fiber and materials hazards. On building site, a lot of dust is created. An invisible, fine and poisonous mixture of fiber and hazardous compounds frequently make up the dust at construction sites. This can harm the lungs and cause conditions like asthma, silicosis, and chronic obstructive pulmonary disease. Falling from height. Due to the height and constantly changing conditions, there is obviously a greater risk of accident at construction site. Incomplete roofing, holes, and temporary scaffolding on building site all pose risk and call for careful consideration and planning in order to minimize falls from heights. Falling object hazards. The most frequent bruises, fractures, strains, and sprains sustained by workers as a result of falling objects are these. The items that frequently fall range in size from huge ones like steel beams and roof trusses to little ones like fasteners and small hand tools, from falling or from very far falling.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Akil Faik, metric number AF 2095. Next is hierarchy analysis. For analysis of identify hazard, when conducting a hazard analysis, it is essential to identify potential risks and hazard within a specific context, such as workplace or a project. Here are the steps involved in analyzing identify hazards. The first step is hazard identification. This step involves systematically recognizing potential hazards that could cause harm, damage, or adverse effect. Hazards can include physical, chemical, biological, ergonomic, or psychosocial factors. The second step is risk assessment. Once hazards are identified, risk assessment is performed to evaluate the likelihood and severity of potential harm or damage. This assessment considers factors such as the frequency and duration of exposure, the level of risk tolerance, and the potential consequences. The third step is risk evaluation. In this step, the assessed risks are evaluated based on predefined criteria, which may vary depending on the organization or regulatory requirements. The evaluation helps determine the significance of each identified risk. The last step is risk control. Risk control involves implementing measures to minimize or eliminate hazards, reduce the likelihood of harm, or mitigate potential consequences. This step includes selecting and implementing appropriate control measures such as engineering control, administrative control, and personal protective equipment. For HIRAC process, HIRAC stands for Hazard Identification, Risk Assessment, and Risk Control. It is a systematic approach widely used in occupational health and safety management to ensure hazards are identified, evaluated, and controlled effectively. Here's a breakdown of the HIRAC process. The first step is hazard identification. This step involves identifying potential hazards within a specific context or workplace. Hazards can be identified through inspection, incident reports, audits, and employee feedback. The goal is to create a comprehensive list of potential hazards. The second step is risk assessment. Once hazards are identified, a risk assessment is conducted to evaluate the likelihood and severity of potential harm. The assessment considers various factors, including the nature of the hazard, the level of exposure, and the vulnerability of individuals. This step helps prioritize risk and determine the level of control required. The third step is risk control. After assessing risk, control measures are implemented to minimize or eliminate hazards. Control measures can include engineering controls, administrative controls, and the use of personal protective equipment. The last step for hierarchy process is communication and training. It is crucial to communicate, identify hazard and control measures to employees, contractors, and relevant stakeholders. Training programs should be conducted to educate individuals on recognizing hazard, understanding risk, and following proper safety procedure. This is our hierarchy analysis based on the building at G3UTHM. Based on this analysis, the most critical safety hazard in maintaining outbuilding is performing electrical wiring. The rate for this hazard is 16, which shows the risk is at high level. The most critical health hazard for maintaining outbuilding is wearing unsuitable PPE during works. The rate for this hazard is 13, which determines the risk is at high level. By following the hierarchy of control, there are two methods that can be implemented to overcome this health hazard. The first method, in this case, is less effective, that will be relying solely on personal protective equipment as the primary control measure. And the preferable to implement higher level controls is such as elimination, substitution, or engineering controls before relying on PPE as the sole protective measure.
The control measure for electrical hazard is circuit protection devices. Circuit protection devices are designed to automatically limit or shut off the flow of electricity in the event of ground fault, overload, or short circuit in the wiring system. The ground fault circuit interrupter, or GFCI, is designed to shut off electric power if ground fault is detected to protect the user from potential electrical shock. One of the control measures for manual material handling is engineering controls. The best and most efficient way to reduce employee exposure to repetitive motion injuries, or known as RMI, is automation. The example of the automation is forklift. Lastly is the control measure for falling from height. Falls may be avoided by using scaffolding, but it must be placed correctly and built solidly enough to support the necessary weight load. Next is construction workers may be protected by the installation of fall prevention equipment such as guardrails, toolboards, screens, canopy structures, or netting.
Workplace hazards are one of the reasons why people throughout the world suffer from significant damage to their human body systems. To minimize and eliminate workplace dangers, collect data, investigate, and classify causes of accidents that are likely to occur if the hazard is not avoided. To avoid unfortunate occurrences, companies should provide workers with a safe and well-planned environment, which should cover and implement all the levels of employee safety, while motivating employees to report any potentially hazardous activities posed or machinery. Every worker in the working sector should be provided with proper personal protective equipment. PPE is critical and should be required, especially when exposed to harm and visible threats. Furthermore, every employee should be well informed about potential hazards in the workplace. Employers also play an essential role in this aspect because they are responsible for providing a safety training program as well as workers' insurance.